Van der Waals forces are the weakest of the chemical bonds that we are going to consider in biological systems. To understand van der Waals forces, consider two molecules, A and B, with some chemical bonds. These are 5 atoms. Exactly what they are doesn't matter to us. What does matter is that each of them has electrons that are not fixed in place. By chance, you can have more of the electrons of molecule B toward one side, which makes the other side a little bit positive, and more of the electrons in molecule A toward one side, which makes that side negative and the other a little bit positive. That slight inequality of charge, even though it's temporary, will attract these two molecules together. Those are van der Waals forces. The distances matter. Van der Waals forces act over distances of about 0.4 to 0.6 nanometers. That's about 400 to 600 picometers. For reference, a carbon-carbon bond is about 0.15 nanometer. What I've tried to draw here is a carbon-carbon bond that's about 0.15, and this distance should be about 3 to 4 times that. Looks like I may not have gotten it quite right, so we can move this a little bit further apart. What happens if these two molecules are closer together is that the forces become repulsive. Their electron clouds are interfering with each other and they're repulsed. You can diagram van der Waals forces as a sketch for yourself more simply. We need two molecules, a carbon-carbon bond for reference, and you want the distance between these two to be about 3 to 4 times the length of your carbon-carbon bond. Remember, that's 0.15 nanometers. This should be about 0.4 to 0.6 nanometers. You need to indicate that the electrons on each of them, at least temporarily, are tending toward one side of the molecule. If the electrons are trending here, this side's a little more positive. If the electrons are trending there, that side's a little more positive. This one's a little bit more negative. And that temporary transitory difference in charge will attract these two molecules together. You could add another molecule over here. If its electrons are off to one side, this one's going to be positive, and again, you'll get attraction. The differences in distribution of electron are brief, so they're not very strong, and that makes van der Waals forces the weakest of the molecular forces that we're going to consider. But molecules can have many different parts of the molecule close to each other, and van der Waals forces can be very important in holding molecules together in biological systems.